Hello, dear viewers. I am Engineer Kamran Khan, and you are watching my YouTube channel, Learners of Civil Engineering. Guys, today I will be discussing my second lecture, which is related with the subject of soil mechanics. And the title of today's topic is Residual and Transported Soil. Guys, as you know, that soil is a product of weathering. So, after weathering, the soil which will be produced will either stay in its original location or it will be transported to new locations with the help of different agents. Okay, in which case it will be called as a transported soil. And let's suppose if the soil will remain in its parental location, in that case it will be known as a residual soil. So if the rate of weathering will be more as compared with the rate at which the soil will be transferred to different areas by different transporting agents, will result in a residual soil. Okay, now residual soil will be having a characteristic boring like the bigger particles will go to deeper depths and the finer particles will remain near the surface of the earth. Like I'm giving you an example of the weathering of a granite rock. When granite undergoes weathering, it results in clay or silty clay material, silty or sandy soil, the partially decomposed granite, and at the bottom there will be bedrock. So now let us see the boring log of that rock. You can see at the bottom there will be undecomposed bedrock. Okay, the granite which will not be decomposed. On top of it will be the partially decomposed granite, in which the size of the particle will be bigger. On top of that, you will be having silty sand, the particles of which are finer than the partially decomposed granite. So it lies on top of the partially decomposed granite, and on top of the silty sand, you will be having this light brown clay silt, the sizes of which are less than the size of silty sand. So it remain on top of the silty sand, and on top of the clay silt, you will be having silty clay because the sizes of silty clay are finer than silty clay silt. Okay, the size of silt is less than 2 micron. Okay, the size of clay silt is 75 to 2 micron, and the size of sand is from 4.75 to 75 micron. Now let us discuss the transported soil. When the rate of weathering will be less as compared with the rate of transportation, then it will result in different types of transported soil. The first step is, or the first type is gravity transported soil. Now in this, gravity is an agent which results in the transported soil. Now gravity is the slope, or gravity is the difference of levels among the different points which will result in the transportation of a weather material. Okay, now there are different phenomena involved in the gravity transported soil. The first one is the creep. Now residual soils on a natural slope, when they will move downward in a gradual or slowly fashion. Okay, in which case the movement of a residual soil will be known as creep. Okay, and if this movement is sudden and rapid, okay, if this downward movement of soil is sudden and rapid, then this will be called as a landslide. Now, mud flow. Mud flow is a case in which a highly saturated loose sandy soils, okay, on a flat surface, okay, highly saturated loose sandy soil on a flat surface comes downward and achieves a more dense and compact condition on a flat surface, okay, in which case this will be called as a mud flow. Now you can see there is no clay or silt involved, but still we are calling this process as mud flow because in this the sand is highly saturated, okay, and when it comes to rest on a flat surface, then its condition will become high dense. So that's why we can call this as a mud flow. Now, the soil deposits resulted from creep, landslides, and mud flow are cumulatively called as colluvial soils. Okay, so colluvial soil, I would rather say, is the gravity transported soil. Now comes the alluvial deposits. Okay, now alluvial deposits is the term used for the deposits formed by water currents. Okay, so when the weather material will be eroded, reshaped, and redeposited in a non-marine environment by water in the form of loose and unconsolidated soil mass will be called as alluvial soil deposits. In this process, the water will first do the erosion, okay, then reshaping. When the heat water currents will take the soil particles, then the soil particles may collide with each other in the way, in which case their shape will become changed because they will be broken down into different shapes, into different pieces, and they will be redeposited in different way. Let's suppose if their parental location there was sand at the bottom, then silt, and then clay, then maybe at the new location the clay will be at the bottom, the sand will be in the middle, and the silt will be at the top. Okay, so this is known as redeposition. Now the alluvial soil deposits may be further divided into two categories. Number one is the braided stream deposits, and number two is the meandering belt deposits. Now let me discuss the braided stream and deposits. Okay, so now when high gradient streams, okay, in high gradient streams, the velocity of flow of water, as you all know, is high. Okay, so this high velocity will do the erosion of the banks and the beds of a river, and a huge amount of sediment will be transferred from one location to another location via the huge currents of water. Okay, but when the bed of the stream will become a little uh, flat, then at this flat location the velocity of flow of water will decrease, and it will result in the deposition of a huge amount of sediments, which will result in such type of islands. Now you can see these islands are known as braids. Okay, so that's why it is known as a braided stream deposits, because their borlaug or their structure is more like a human hair braid. Okay, so that's why these are known as braided stream deposits. And the characteristics of those braid stream deposits is that they are very irregular in stratification. Their strata is very irregular and they are having a wide range of grain sizes. Now let me explain these two things with the help of this diagram. Now you can see this is a cross section of a braided stream deposit, okay, in which this zone is taken by the coarse sand, upon which you are having a gravel layer, okay, you can see it is mentioned here, and then the silt layer is embedded in this spiral form between gravel and coarse sand, and on top of that is the fine sand. So now you can see this is more like the braid of a human hair. So that's why they are called as braid stream deposits. Now, as I told you that they are very irregular in stratification. Now you can see the strata is not regular because all the particles are just intermixed in the form of different spirals. Now let us discuss the meandering belt deposits. Okay. Now what is meander belt? So in a mature stream. Now what is the meaning of mature stream? Mature stream is that stream which is moving in an area from the past centuries. Okay, which is old enough, which is senior enough to be called as a mature stream. Okay, so a mature stream in a valley area may curve back and forth, okay, like you can see in this fashion, okay. So when a mature stream will take this winding shape, this swing shape, okay, in an area, then this area will be called as a meandering belt, okay. In meandering belt, now the river banks have two types of shapes. Now you can see this shape, this bank is convex in shape, and that bank is concave in shape, okay, because it moves inward and it moves outward. So this is like convex in shape and this is concave in shape. Now what the phenomena will occur? The water currents will erode the material from the convex portion of the banks, and will try to deposit it at the concave portion of the lake. Okay. Now the material deposited eroded from the convex portions and deposited at the concave portions are called as the conveyor deposits. Okay, and they are usually sand and silt size particles. Now natural levees. During flood overflow, the banks of the river and the areas which are there in the vicinity of the river. Okay. Then after many floods, the flood deposits attain the form of some ridges, some built up banks, in which case they are known as natural levees. Now you can see this is the condition before flood. Nothing is around the banks and on the lowland areas of the river, but after flood there is some deposits, okay, like you can see over here some deposits is there, but after many floods there are some pronounced ridges along the banks, okay. Now these pronounced ridges are built up banks are known as what? Are known as natural levees, and these natural levees are basically sand and silt size particles. Now let us discuss the fourth category of the meandering belt deposits, which is known as backswim deposits. When flood come in the floodplain, flood brings out a lot of small size particles with it, which are known as silts and clay. These clay and silty sized particles are deposited in the form of soft and very plastic uh, particles, which are known as backstream deposits. Okay, and in the backstream deposits, there will be an abundance of highly plastic clays. Now, this is a composite diagram showing you meandering belt, oxbow lake, pond bar deposits, natural levees, and the bake swamp deposits. Now let us discuss the other category, which is known as a lacustrine deposits. Now in arid regions are those regions which are dry enough. Uh, in those areas, the rainfall quantity will be much less, and the water table will be much below the natural surface level. In those areas, the streams having a characteristics that the streams over there carry large amounts of suspended particles. Now, when these streams will try to enter a lake, then a region will come when the granular or the bigger particles will be deposited in the shape of different islands. Okay, and this island portion will be known as a delta. Now the finer particles like the silt and clay particles will move to the lake and will be deposited in alternate layers of coarse and fine grained materials, in which case they are called as a lacustrine deposits. Now let us discuss the glacier deposits, in which I will discuss the glacier drift. Now, glacier drift is a term usually applied to the deposits laid down by glaciers. The deposits, the deposits which are formed from glaciers are known as glacier drift. Now, this glacier uh, drift will try to form some unstratified deposits consisting of boulders, gravels, sand, silt, and clay as particles, which will weigh several ton. Okay, will be known as till. So till is like the mixture of the material deposited from glacier drift, and the different landforms that are the results of the deposits of till are known as moraines. Okay, the till will be deposited in different shapes, and these shapes will be called as moraines. Now there are many types of moraines: end moraine, terminal moraine, ground moraine, lateral moraine, and the medial moraine. Now let us discuss the end moraine. Okay, so end moraine you can see in the image, they are known as end moraines. They are formed at the terminus of the glacier. When the glacier advance will become seas, so the different shapes of the till over here are called as the end moraine. Okay. Now, what is the terminal moraine? This last shape of the till is known as a terminal moraine. Now, terminal moraine is the ridge of till that marks the maximum limit of a glacier advance, beyond which there will be no flow of glaciers. All the deposit, all the huge and bulky particles will be deposited in the terminal. moraine, and some sand, silt, and gravel, fine gravel size particles, okay, which are carried by the melting water from the front of a glacier, are known as outwash. Now this is outwash. Outwash is basically the mixture of the fine grained materials. It has been carried away beyond the terminal moraine. Now let us discuss ground moraine. Ground moraine, this is the space reserved for the ground moraine, okay, in which the shape of the till will become a flat, okay, a gentle undulating plane in between the end moraine is called as a ground moraine. Now the lateral moraine, okay, the debris of glaciers deposited along the sides of the valley are called as the lateral moraine, okay, and now what is the medial moraine? So when the two glaciers try to meet to have a single combined flow, so the ridge of till that will be formed between them will be called as a medial moraine or the center moraine. Now let us discuss the Aeolian soil deposits. Okay, so the soil deposits formed from a wind are known as Aeolian soil deposits. Okay, as you all know that wind is also a major transporting agent of the weather material. So when a large quantities of sand lies exposed, they may be transported from one location to another location by the huge currents of wind. Okay, and such type of landsforms will be made, which are known as sand dunes. Okay, now, the characteristics of that sand dunes is that on the windward side, like this is the windward side, okay, which is prone to wind or which is facing the wind, will be having a compact type of material, and on the leeward side, okay, this is the leeward side, which is opposite to the windward side, okay, we'll be having some loose type of material, because when the particles will reach on the crust of the dune, then they will try to roll and will be deposited in a loose form around the leeward side of the dune. But on the windward side, this particle will be compacted by the currents of water. Okay, so if you want to study the some typical characteristics of the dune shed, so the grain size distribution of the sand at any particular location is surprisingly uniform, because sand will carry the smaller particle farther onto the areas, like let's suppose the bigger particles will be carried to smaller distances, and the finer particles will be carried to the farther areas. So in this shape, you can see that if you will want to check a particular location, then the grain size distribution will be uniform at any particular location. Then the general grain size decreases with distance from the source, because the wind carries the smaller particles farther than the larger ones, like you can see in this picture. Okay, that sand can carry the smaller particles to far areas as compared with the bigger ones, and the relative density of the sand deposited on the windward side may be as high as 5 to 50 to 65%, increasing to about 0 to 15% on the leeward side, because on the leeward side there will be no force of compaction. There will be only a free fall rolling movement of the sandy particles. But on the windward side, there will be an action of compaction by the wind. Now let us discuss the organic soil. Organic soil are found when the water table will be near or above the ground surface. Okay, so the presence of high amount of water will helps in the growth of aquatic plants, and when these aquatic plants will decompose, then they will be mixed in soil, and the soil will become organic in nature. Okay, these soils are usually found in coastal areas of rivers, streams, and oceans, and in glaciated regions. The typical characteristics include the natural moisture content range from 200 to 300%, like a very high moisture content. Okay, they are highly compressible, and they exhibit large amount of settlement and secondary consolidation. So these three characteristics make the organic soil as a very poor type of soil, which is not suitable for any type of consumption. Guys, I hope this video was useful for you. Kindly like and share the video. Subscribe the channel and press the bell icon for further updates. Thank you so much. God bless you.